Before oil and gas production can be sold, testing and measuring must be performed to ensure the production is suitable for market and verify the volumes being sold. In this lesson, we'll look at the factors that must be considered during testing and measurement, along with how volumes are measured. We'll also address the topic of oil and gas production allocations. First, let's discuss crude oil measurement. Oil is measured in barrels, with a barrel being equal to 42 gallons. Several factors can significantly affect both the quality and quantity of crude oil. These factors include temperature, API gravity, and the presence of basic sediment and water, often abbreviated as BS&W. The temperature of oil in a stock tank is generally close to that of the air surrounding the tank. However, the temperature may be elevated if the oil has just been produced or has been heated in a heater treater at the gathering system. The temperature of the oil affects its overall volume because, like other fluids, oil expands or contracts in response to temperature change. Think of a water bottle breaking if the water accidentally freezes. To compensate for this, crude oil and product measurement volumes are adjusted to a standard temperature of 60 degrees Fahrenheit. API gravity refers to a measurement index developed by the American Petroleum Institute, which describes how heavy or light oil is in relation to water. API gravity is expressed in degrees. The API gravity of water is 10 degrees. If the oil's API gravity is above 10 degrees, it is considered light and will float on water. If the API gravity is less than 10 degrees, the oil is considered heavy and will sink. API gravity determines how much the oil is worth because light oil will produce a higher yield of gasoline or diesel when it is refined. And remember, the higher the API number, the better the quality of crude oil. Even after treatment, some BS&W remains in oil. Since these are impurities and not part of the actual marketable oil, they must be carefully measured, removed with treating, or factored into the value if still in the crude oil. The testing and measurement of crude oil is typically done by a lease automated custody transfer or LACT unit. These are self-contained, automated, skid-mounted units found at the well site, along the pipeline, or prior to entering a storage facility. A LACT unit determines the temperature, API gravity, and BS&W content of oil. It can also divert the flow of fluids and send unacceptable oil back to the treating system for further processing. A LACT unit measures the volume of oil and transfer of ownership, or custody, of the oil from the lease owner to the pipeline. At older, smaller leases, where oil is hauled away in a tank truck, production can be measured by a meter or by manually measuring the change in the volume in the stock tank. In either case, samples are taken from the oil to test for temperature, API gravity, and BS&W content. Now let's discuss factors impacting natural gas measurement. Natural gas volumes are measured in cubic feet. A cubic foot of natural gas is the amount of gas that can be contained in a cube 1 foot on a side, at a certain standard temperature and pressure. Temperature and pressure affect the amount of gas that can be contained in a 1 foot cube. At a higher pressure, more gas can be contained within the cubic foot of space. Conversely, at a higher temperature, less gas can be contained in a cubic foot of space. When gas is measured, its pressure and temperature must also be measured. Its actual volume at its actual temperature and pressure can then be adjusted to show what volume the same gas would have at a standard temperature and pressure. The industry standard conditions for gas volumes is a temperature of 60 degrees Fahrenheit and a pressure of 14.7 pounds per square inch absolute, or PSIA. These standards are called ambient temperature and pressure. Gas measurement is done differently than oil. and is called gas metering. This is the process of measuring the volume of natural gas flowing past a particular point. Gas volumes are measured using an orifice meter or a turbine meter. An orifice meter has a plate with a hole in its center that is mounted vertically in a gas line. When gas flows through the orifice, measurements of the pressure difference on each side of the orifice plate are taken to calculate the volume flow rate. A turbine meter has a windmill-like device in the flow line which measures the velocity of the natural gas flow. The faster the flow rate is, the faster the blades rotate. The speed of the flow is directly proportional to the volume of gas. Both orifice and turbine meters have temperature and pressure sensors to make appropriate adjustments to the ambient temperature and pressure when calculating flow volumes. Now, let's discuss production allocation. Many producing wells in the U.S. have multiple participants, called interest owners, that helped finance the well or field development. Each interest owner is entitled to its share of the well's production. This is especially true for large, expensive offshore and deepwater discoveries. Once oil and gas production is ultimately delivered for sale, the final sale volumes and revenues need to be allocated back to the applicable interest owners. Production allocation is the term for this process, and it can be quite complex. This is because the infrastructure used to gather, store, and transport oil and gas is also shared among multiple operators. Typically, the well and/or field operator will maintain a production accounting model which calculates how much production from each well is attributable to each participating interest owner in the well. This model produces a monthly pipeline balancing report that is then sent to each interest owner to get their fair share. In jointly owned operations, it is often not practical for each entity or small interest owner to sell its exact share of production during a month. This can result in imbalances where some owners have taken more or less than their entitled share of production. These imbalances may be settled in future months by an interest owner taking more or less production as needed. Or, cash balancing may also be done where an interest owner that has taken more than its entitled share makes a cash payment to another interest owner that has taken less than they were entitled.